Good evening and welcome to the Sleepy Geographer. This is your quiet place to set aside the busyness of the day, to let your thoughts slow down and to drift into a story of the earth told in gentle detail. Tonight's journey takes us into the frozen world of ice, the silent force that has carved mountains, shaped valleys, and even influenced the rhythm of the climate. From ancient glaciers to hidden permafrost, we will explore how ice has been an architect of our planet's landscapes. Before we begin, I would love to know where you are listening from. It is always fascinating to see the many corners of the world that gather here in this calm space. If you enjoy this video, a kind like and a gentle tap on subscribe would mean a lot. And to those of you who are already subscribed, thank you deeply for returning time and again to join these quiet journeys. Now, I do hope this video is not so interesting that it keeps you wide awake, but if it does, at least you might drift off later with a head full of glaciers and icebergs instead of tomorrow's to-do list. So settle in, let your mind rest, and let me ask you this. What if the frozen silence beneath your feet was not just stillness, but a memory of the earth itself? Ice is more than frozen water. It is a storyteller of deep time, a sculptor of continents, and a quiet regulator of the climate. When you picture the world covered in white during an ice age, you're seeing not just a frozen landscape, but the planet undergoing one of its most dramatic transformations. Entire mountain ranges have been carved smooth by glaciers, and vast plains have been reshaped under the weight of ice sheets that once stretched across half a continent. Ice is also a record keeper. Locked within its layers are bubbles of ancient air, traces of volcanic eruptions, and delicate signals of past climates. By reading these frozen archives, scientists can trace the breath of the planet back hundreds of thousands of years, learning not just what the Earth was like, but why it changed. And though it seems motionless, ice is never truly still. A glacier is a slow river, flowing under its own immense weight. Crevasses open like scars, icebergs carve with thunder into the sea, and frozen rivers inch their way down valleys at a pace almost too slow for human eyes. This gentle persistence is what makes ice such a powerful force, quiet, patient, and unstoppable. Yet ice is not only a relic of the past, it is a living part of the present, shaping coastlines, feeding rivers, and cooling the planet through its reflective brightness. Its presence, or its absence, changes the balance of climate across the globe. What happens in Antarctica or Greenland can ripple into the monsoons of Asia, the droughts of Africa, and the rising seas that reach every shore. In this journey, we will wander through the frozen landscapes of the world, the glaciers of the mountains, the vast sheets that cloak entire continents, the permafrost that holds ancient secrets, and the fragile sea ice that floats with the polar winds. Together they are not only reminders of a colder Earth, but active participants in shaping the one we live in now. As we explore these frozen realms, the question lingers: are we living at the end of the age of ice, or simply another chapter in its long, silent story? Long before people walked the Earth, long before forests swayed or oceans filled with whales, there was ice. Not the scattered patches we see on mountaintops today, but vast, unthinkable stretches that wrapped the entire planet in a frozen shell. To imagine this beginning is to step into the very deep past, when Earth itself was still experimenting with climates and landscapes, still testing the balance between warmth and cold. Ice first appeared on Earth billions of years ago. Our planet formed hot, a molten ball glowing in the dark, but as it cooled, water condensed to form oceans, clouds gathered, and the first hints of frozen crystals formed wherever temperatures dipped. Early evidence suggests that icy conditions existed as far back as 2.5 billion years ago, when the sun was weaker than it is now. Yet even under that fainter sun, Earth sometimes managed to keep its waters liquid thanks to greenhouse gases in the air. It was a fragile balance. One shift too far, and the planet tipped into freeze. The most dramatic of these plunges is known today as Snowball Earth. Picture it. The oceans locked under kilometres of ice, continents buried beneath thick white sheets, and temperatures so low that even the tropics lay silent and frozen. These snowball episodes are thought to have occurred multiple times, the most famous taking place around 700 million years ago. Evidence comes from rocks in Namibia and Canada that show signs of glacial movement right at the equator, scars left by ice where no ice should have been. What could have plunged Earth into such a state? The answer lies in feedback loops. When ice spreads, it reflects sunlight back into space. This is known as albedo. More ice means less heat absorbed, which means colder temperatures, which means even more ice. It is a runaway train of cooling. Once the process began, it may have covered nearly the whole globe. For tens of millions of years, Earth sat in this frozen stillness, the atmosphere thin and cold, the ocean sealed away beneath a solid roof. And yet, life endured. Tiny microbes huddled in pockets beneath the ice, near volcanic vents, or wherever a drop of liquid water remained. These organisms may have been pushed to the edge, but they survived, and in doing so, they proved life's remarkable resilience. When volcanism eventually released enough carbon dioxide to trap heat, the great ice locked on the surface began to melt. With suddenness almost hard to imagine, Earth thawed. The aftermath of these freeze-thaw cycles is thought to have set the stage for one of the most important leaps in biological history, the rise of multicellular life. To grasp the scale of this transformation, picture entire mountain ranges ground down by slow, creeping glaciers, their jagged edges polished into sweeping valleys. Imagine continents shifting under the weight of ice, crust bending downward like a bow under strain. Ice did not simply cover the land. It pressed, scraped, and carved. It was not a passive blanket, but an active tool, sculpting the face of the world. When the ice sheets retreated, they left behind landscapes utterly transformed. New lakes, new plains, and fresh soils spread across once barren rock. This was the dawn of ice as a true architect of Earth's geography. Even in the ancient past, its fingerprints were etched into stone. Dropstones, for example, are lonely boulders stranded in layers of fine sediment, carried far from their origin by glaciers before being dropped as the ice melted. These geological souvenirs still tell us where ice once reached. Moraines, too, formed as ridges of rock debris piled up at the edges of glaciers, marking their furthest advance. Each of these features whispers a story of motion, weight, and persistence. The power of ice in deep time also reminds us that it is not merely a local force. Unlike a river that shapes only its valley, or a volcano that builds only its mountain, ice has the capacity to transform continents. In the snowball Earth phases, it shaped the entire planet's surface at once. Even in less extreme ages, glaciers covered North America, Europe, and much of Asia. At its height, ice influenced sea levels, climates, and ecosystems across the globe. When sheets expanded, sea levels fell as water was locked on land. When they retreated, seas surged back, drowning coasts and reshaping shorelines. It is almost poetic to think that this cold, slow-moving substance was responsible for such sweeping change. Ice works on timescales far beyond human reckoning. Where we measure days and years, it measures in tens of thousands of years, in entire geological epochs. The grooves carved into granite cliffs, the valleys hollowed out between mountains, and the plains that stretch across continents are all testaments to its patient labour. One might imagine the planet in these early ages as a restless experiment, flipping between fiery warmth and icy stillness, trying on different climates the way a person might try on coats. The snowball Earth events were extreme versions of this, dramatic tests that nearly ended life as we know it, but ultimately pushed it to adapt and evolve. The legacy of those frozen chapters is not just written in stone, but also in the very fact that complex life emerged soon afterward. Ice in deep time was more than a frozen inconvenience. It was a creative force, Its advance and retreat sculpted the foundations of continents. Its vast expanses influenced the chemistry of oceans, altering circulation patterns and nutrient flows. Even today, echoes of those ancient frozen worlds are found in the structure of our landscapes and the distribution of life. When we walk through a U-shaped valley or stand by a glacial lake, we are seeing the outcome of processes that began billions of years ago. These features are not recent accidents, but part of an ancient story, one where ice was both destroyer and creator. Without those frozen episodes, Earth might look far less dramatic, its mountains rougher, its valleys narrower, its soils thinner. Ice has given the planet much of its character, often without us even realizing it. And so the story of ice begins not with silence, but with drama. Entire worlds frozen over, seas sealed shut, and continents ground into new shapes. From the very start, it has been a restless partner to rock and water, testing the strength of life and reshaping the face of the globe. The frozen hand that once held Earth in its grip has never truly let go, leaving marks across deep time that remain visible even now. A glacier does not arrive on the landscape in an instant. It is not born with a sudden crack or collapse. Instead, it emerges slowly, almost imperceptibly, from the quiet layering of snow upon snow. Year after year, storm after storm, delicate crystals fall from the sky, each one tiny and temporary, but together forming something immense and enduring. What begins as a soft winter blanket can, with time and pressure, become a river of ice, powerful enough to grind mountains to dust. The first step in this transformation is accumulation. In high mountain valleys or near the poles, where summers are too short or too cool to melt all the winter snowfall, layers of snow begin to linger. The following year, new snow piles on top of the old, and the process repeats. At first, the snow remains light and airy, a frosty quilt. But as the layers grow, the weight above presses down on the snow beneath. The delicate six-pointed shapes collapse, losing their sharp edges. The air between flakes is squeezed out and the snow becomes denser and coarser. After a few seasons, this compacted layer is no longer snow in the ordinary sense. Geographers and glaciologists call it firn. Firn is an in-between state, not quite snow, not yet solid ice. Imagine walking on it and feeling the crunch give way to something more resistant, almost as if the ground itself has begun to harden. Firn grains are rounded, icy pellets that continue to pack together under pressure, and as they fuse, they begin to resemble true glacial ice. Given enough time and enough snowfall, this transformation deepens. The firn compresses further, air bubbles are trapped, and the material becomes clear, dense ice. In mountain regions, this change might take decades. In polar areas, where accumulation is slower, it may take centuries. But once it happens, once the weight grows beyond a certain point, the ice begins to move. This is the birth of a glacier, not as a static frozen slab, but as a dynamic body with its own slow-motion flow. It is here that glaciers reveal their true character. They are often called rivers of ice, and for good reason. Under immense weight, ice behaves in surprising ways. Though it is brittle and breakable on small scales, think of the sharp crack of an ice cube in a drink. On the scale of mountains, it can bend and deform. The enormous pressure of kilometers of ice makes the lower layers creep like a thick, viscous fluid. This creeping flow allows a glacier to slide, ooze, and grind its way downhill, pulled by gravity toward lower altitudes. Of course, the movement is not uniform. Near the surface, where pressure is less and temperatures are colder, the ice tends to crack rather than flow, forming deep crevasses that gape open like frozen wounds. These fractures remind us that the glacier, while slow and silent, is always under stress. Below, however, the ice deforms plastically, shifting over bedrock like cold honey poured too slowly to sea. The two behaviours together, brittle on top, plastic beneath, give glaciers their distinctive layered personality. Gravity provides the pull, but the base of the glacier also plays a role. where the ice meets the ground, a thin film of meltwater often forms, created by pressure or by geothermal heat seeping up from below. This lubricates the glacier, allowing it to slide more easily over bedrock. In some regions, whole glaciers surge forward, advancing rapidly when lubrication increases, then slowing again when conditions shift. The result is a landscape always in motion, though the pace is too slow for an impatient observer to notice. To give a sense of scale, many glaciers move only a few centimetres to a few metres each day. That is glacial speed. The very phrase has become a metaphor for slowness. Yet measured across centuries, these rivers of ice travel astonishing distances, carving valleys, pushing debris, and redrawing the land. Their progress is not rushed, but their impact is immense. The story of how glaciers form also includes the delicate balance between accumulation and ablation. Accumulation is the input, the snowfall added each year. Ablation is the output, the melting, evaporation, and carving of icebergs that takes material away. A glacier survives only when input outweighs output. If melting exceeds snowfall, the glacier retreats. If snowfall dominates, the glacier grows. In this way, a glacier is like a ledger book, recording the balance of climate in ice. Different environments give rise to different kinds of glaciers. In high alpine valleys, mountain glaciers snake their way down narrow paths, often feeding rivers far below. On polar plateaus, ice sheets spread across vast expanses, their weight so great that they deform the very crust of the earth. Regardless of size, they all begin the same way, with the humble accumulation of snow compacted over time into ice that begins to creep under its own weight. The transformation from snowfall to glacier also traps tiny records of the atmosphere. As firn becomes ice, bubbles of air are sealed within. These are time capsules, preserving samples of ancient atmospheres that scientists can later study. Each bubble tells of the air that once swirled above the snow, of the gases that fill the sky, of volcanic eruptions, forest growth, and the breath of ancient oceans. Thus, the birth of a glacier is also the birth of a memory, frozen into place for thousands of years. There is also something poetic in the way glaciers embody patience. Snowflakes, fleeting and delicate, last only moments in the air before melting or vanishing. But when they fall in the right place, at the right altitude, they become part of something larger. Each flake contributes to a structure that may endure for millennia, long after the storm that dropped it has been forgotten. The glacier is a monument built grain by grain, a cathedral of ice assembled by weather and time. To stand at the edge of a glacier and know this story is to see more than ice. It is to see the steady hand of climate, the slow alchemy that transforms snowfall into rivers of frozen stone. The gleaming surface, riddled with crevasses and meltwater streams, hides the centuries of quiet labour beneath. Every shimmering wall of blue ice began as a fragile flake, a reminder that even the smallest and softest of beginnings can accumulate into forces that shape the earth. When a glacier finally takes shape, sliding down valleys or spreading outward across plains, it announces itself not with noise but with presence. Mountains bear the marks of its passing, valleys widen under its grip, and entire ecosystems adapt to its advance or retreat. The journey from snow to glacier is not merely a physical change. It is the unfolding of a process that is repeated across epochs, turning delicate winter snowfall into rivers of ice capable of carving the bones of continents. Ice is more than a frozen presence on the land. It is a sculptor with a patient hand and a steady chisel. Over tens of thousands of years, glaciers carve into rock, scrape across plains, and reshape entire landscapes in ways that water or wind alone could never achieve. Where it flows, it leaves behind valleys and lakes, ridges and hills, each one a signature of its slow yet relentless artistry. To look at these features today is to glimpse the silent work of ice, a craftsman that takes millennia to complete a masterpiece. One of the most distinctive forms created by glaciers is the U-shaped valley, Unlike rivers, which tend to slice through bedrock in narrow V-shaped gorges, glaciers fill entire valleys with ice. As they move, they grind against both the floor and the sides of the valley, widening it and smoothing it into a sweeping U. Imagine standing in Yosemite Valley in California. The granite walls rise almost sheer, yet their shape is not jagged but rounded, softened by the steady push of glaciers that once filled the valley to its brim. The famous El Capitan and Half-Dome cliffs are testaments to this carving, giant sculptures polished by ice, now towering over the meadows below. Then there are fjords, perhaps the most dramatic works of glacial art. A fjord is a drowned glacial valley, where the sea has flooded in after the ice retreated. Norway is famous for them, with vast waterways like Sonnefjord and Geirangerfjord slicing deep into the land. Their walls plunge almost vertically into dark waters, cliffs streaked with waterfalls that tumble hundreds of meters to the sea. These landscapes feel otherworldly because they are the result of two forces: glaciers carving valleys far below sea level, and the ocean later filling them with salt water. Standing at the edge of a fjord is to look into a cathedral built by ice and tide together. At higher altitudes, glaciers often scoop out bowl-shaped hollows known as cirques. These amphitheatre-like basins are where many glaciers are born, collecting snow and ice that feeds the slow river below. In the Alps, cirques cradle small mountain lakes, perfectly round and startlingly blue, often called tarns. They resemble delicate fingerprints of ice, tucked into the shoulders of peaks. Each one is a reminder that glaciers not only shape the broad strokes of continents, but also carve out intimate hidden spaces where water and rock meet in harmony. As glaciers advance, they act like giant conveyor belts, picking up debris, boulders and sand, carrying them along in the ice. When they eventually melt, they drop this load in great ridges called moraines. Moraines can be found marking the former edges of glaciers across the world. In New England, for example, Long Island itself is essentially a moraine left behind by the Laurentide ice sheet at the end of the last ice age. In Switzerland, curved ridges of rock and soil trace the outlines of long-gone glaciers like ancient maps etched into the land. Moraines are not dramatic cliffs or deep valleys, but they are quiet records of how far the ice once reached. Beyond these features, ice also scours and polishes the very bedrock. Glacial striations, long scratches gouged into stone, can be seen on exposed surfaces in Canada, Scotland and Finland. These grooves tell the direction the ice once flowed, like arrows frozen into the landscape. In other places, entire fields of erratics, enormous boulders transported far from their source, rest stranded in meadows, looking as though a giant hand randomly scattered them. One of the most famous is the Pierre des Marmettes in Switzerland, carried by ice from the Mont Blanc Massif and abandoned in a valley miles away. What makes glacial landscapes especially striking is the contrast they produce. U-shaped valleys are wide and gentle, yet they often end in sharp ridges or peaks, where the ice carved deeply around the sides. Fjords combine the softness of water with the severity of vertical cliffs. Cirques are serene hollows nestled beneath dramatic mountain walls. Each form holds a tension between strength and calm, destruction and beauty. Ice erodes, but in doing so it creates some of the most breathtaking sceneries on Earth. Imagine walking through a glacial valley just after dawn. Mist curls along the valley floor, rivers shimmer where meltwater flows, and towering cliffs glow golden with the rising sun. Every curve of the valley walls, every polished slab of granite speaks of ice's long passage. Or picture drifting quietly in a kayak on a Norwegian fjord, the water black and still beneath you, the cliffs rising like immense frozen waves on either side. Waterfalls plunge from high ledges, their spray vanishing before it touches the sea. These sights carry a sense of both grandeur and intimacy, the grandeur of scale, the intimacy of detail carved grain by the creeping glacier. Even in smaller examples, the artistry is clear. In Scotland's Highlands, countless glens trace the paths of vanished glaciers, their rounded shapes giving the land its distinctive rolling character. In Patagonia, where glaciers still descend toward the sea, one can watch the process unfold in real time. Ice carving into turquoise lakes, valleys deepening with each century. To witness a glacier at work is to see geography in motion, though so slow that the human eye cannot catch it without patient study. There is also a hidden side to this sculpting. Beneath the glacier, where ice grinds rock into fine powder, something remarkable is created: glacial flour. This dust of pulverized stone is carried by meltwater into rivers and lakes, where it gives the water a striking milky turquoise hue. Many alpine lakes gleam with this colour, a shimmering reminder that glaciers are not only carvers of land but also painters of water. All of these features together, valleys, fjords, cirques, moraines, striations, erratics, and flour, make up a gallery of ice's work. Unlike human sculptors, glaciers do not choose their subjects or work toward a vision. They act out of physics and pressure, yet the results are landscapes so breathtaking that they seem designed for beauty. Nature's frozen hands have shaped scenes that people now travel across the globe to admire. Perhaps the most remarkable aspect of ice's artistry is its patience. These transformations take thousands, even millions, of years. Each scratch in stone, each widened valley is the product of endless repetition, snow falling, ice pressing, rock grinding. Yet to us the results seem effortless, as if the land was always meant to look this way. That combination of slowness and inevitability is what gives glacial landscapes their unique atmosphere. They feel timeless, older than memory, yet alive with the marks of motion. So when you find yourself in a valley with sheer, sweeping walls, or gazing into the mirrored depths of a fjord, you're standing inside the sculpture of ice. These are not accidents of erosion, but the deliberate work of frozen rivers that once crept through the land. Silent, patient, and unstoppable, glaciers have been the artisans of Earth, chiselling and polishing until the continents bore their signature. And though many of the glaciers have now retreated, their art remains, written across mountains, coasts, and valleys in lines of stone and water. When speaking of ice, it is impossible not to turn to the true giants of the frozen world, the ice sheets of Antarctica and Greenland. These are not simple glaciers winding down a valley, nor even grand fjords carved into a coast. They are vast blankets of ice that cover entire regions, so immense that they reshape the very planet beneath them. Together they hold nearly the entire store of the Earth's fresh water, locked away in frozen form. If all of this ice were to melt, seas would rise by more than 60 meters, flooding cities, swallowing coastlines, and rewriting maps. Their presence is not merely impressive, it is planetary in scale. Antarctica, the larger of the two, is the coldest, driest, and windiest continent on Earth. Beneath its endless white expanse lies a land the size of Australia, yet nearly all of it is hidden under kilometers of ice. The Antarctic ice sheet contains over 90% of the world's fresh water. At its thickest, the ice reaches more than 4 kilometers deep, pressing down on the bedrock so heavily that much of the continent actually lies below sea level, depressed by the colossal weight. The idea that a substance we often think of as fragile, ice, could weigh so heavily on the Earth that it bends the crust is staggering. Greenland, though smaller, is no less extraordinary. Its ice sheet covers roughly 80% of the island, a frozen plateau stretching across the Arctic. Like Antarctica, the Greenland ice is thick enough to push the land down beneath its weight, and though Greenland contains less ice than Antarctica, it is melting more rapidly. This makes it one of the key players in discussions about rising seas. Even a modest loss of Greenland's ice raises global sea levels, with consequences felt far beyond the Arctic Circle. To stand on either of these ice sheets, should one be so lucky, is to experience scale in a way that is almost impossible to describe. The horizon stretches white in every direction, unbroken except by ridges of wind-carved snow. Beneath your feet lies a frozen mass that has endured for millions of years, older than human civilization itself. The stillness is deceptive. for the ice is never fully at rest. It flows outward from the centre, creeping toward the edges where it meets the sea. The flow is too slow to see in a moment, but satellites and careful measurements reveal it as steady and powerful as a river. At the boundaries of these giants lie the ice shelves. These are floating extensions of the ice sheets, vast slabs that stretch out over the ocean, anchored to the land but buoyed by seawater. Some shelves are the size of countries. The Ross Ice Shelf in Antarctica covers an area larger than Spain. They act like giant plugs, slowing the glaciers behind them from sliding into the sea. As long as the shelves hold, the ice sheets remain relatively stable. When they fracture or collapse, the glaciers behind them surge forward, releasing ice at a faster rate. The drama of ice shelves is most visible in the phenomenon of calving. This is when a chunk of ice, sometimes the size of a skyscraper, or even larger than a city, breaks away from the edge of a glacier or ice shelf and drifts into the ocean as an iceberg. The sound is immense, a crack followed by a roar that echoes like thunder. Though calving is a natural process, ice must release as it flows. The frequency and size of these events have drawn attention in recent decades. As waters warm, shelves thin, and their stability wavers. The collapse of the Larsenby ice shelf in 2002, which disintegrated in just a matter of weeks, remains one of the most dramatic reminders of how quickly these frozen giants can change. Icebergs themselves carry their own quiet majesty. Born from the edges of Greenland or Antarctica, they drift across the sea, sometimes surviving for years as they slowly melt. Some tower dozens of meters above the waterline, though this is only a fraction of their true size, with the bulk hidden beneath the waves. They are moving sculptures, fragments of the ice sheets set adrift, carrying with them a reminder of the frozen heart of the poles. Sailors have long feared them for their danger, yet admired them for their strange, crystalline beauty. The influence of the great ice sheets extends far beyond their frozen borders. By locking up so much water, they help regulate sea levels worldwide. Their sheer whiteness reflects sunlight back into space, contributing to the planet's cooling effect. The cold air they generate helps drive atmospheric circulation, influencing winds and weather patterns thousands of kilometers away. In this way, Antarctica and Greenland act as planetary thermostats, vast regulators of climate as much as they are frozen landscapes. Beneath the ice lies another world. Antarctica hides entire mountain ranges, lakes sealed beneath kilometers of ice, and even ancient river valleys buried out of sight. Lake Vostok, one of the largest subglacial lakes, has been isolated for millions of years, shielded from the surface by over 4 kilometers of ice. Scientists believe it may host microbial life adapted to its dark, pressurized environment. Greenland too holds hidden landscapes, including canyons deeper than the Grand Canyon, revealed only through radar mapping. These discoveries remind us that ice sheets are not simply coverings, but portals to unseen realms. The weight of these frozen masses also shapes the Earth's crust in another way, through a process called isostatic rebound. As the ice presses down, it causes the crust to sink. When glaciers retreat, the crust begins to rise again, slowly rebounding like a cushion relieved of pressure. This rebound can take thousands of years. In Scandinavia, for instance, the land is still rising after the retreat of ice sheets that melted at the end of the last ice age. Even in places long free of glaciers, the ghostly memory of their weight continues to reshape the land. There is also a paradox in the perception of these giants. On one hand, they appear eternal, vast, ancient, immovable. On the other hand, they are among the most vulnerable features of our planet in the face of a warming climate. The Greenland ice sheet has been losing mass at an accelerating rate, contributing significantly to present-day sea level rise. Antarctica, once thought more stable, is also showing signs of increased loss, particularly along its western edge where warm ocean currents nibble at the base of ice shelves. The story of these giants is therefore not only one of grandeur but also of fragility. To imagine the consequences of their retreat is to imagine profound change. Coastal cities from New York to Shanghai, from London to Lagos, sit only a few meters above current sea levels. Small island nations would be swallowed, deltas would flood, and millions of people would be displaced. All of this is contained in the frozen vaults of Greenland and Antarctica. These regions are not distant curiosities but central players in the future of human societies, and yet, for all their scientific importance, there is also a quiet poetry to them. The endless horizon of Antarctica, broken only by the shimmer of blue shadows on snow, has an otherworldly serenity. The Greenland ice sheet, gleaming under the midnight sun, reflects a brilliance that feels timeless. They are landscapes of silence, where wind and ice sing the only songs. They remind us that Earth holds extremes, that it can be both lush and frozen, gentle and merciless, fragile and vast. These ice sheets are, in a sense, the breathing of the planet frozen in place. They grow with snowfall, they release through melting and calving, they advance and retreat over ages, they embody both motion and stillness. To study them is to study the heartbeat of Earth in slow motion, measured not in seconds but in centuries. The giants of Antarctica and Greenland stand as guardians of Earth's water and climate. Their sheer scale is humbling, their influence undeniable, their presence both majestic and precarious. They are the silent monarchs of the frozen world, shaping seas, weather, and the fate of coasts. To understand them is to understand not only ice, but the delicate balance that allows our planet to remain habitable. And as they continue their quiet reign, we are reminded that even the most seemingly immovable features of Earth are part of a story still being written. Permafrost is one of those quiet features of the Earth that hides in plain sight, rarely noticed but enormously significant. By definition, it is ground that remains frozen for at least 2 consecutive years, though in many places it has stayed locked in ice for tens of thousands of years. Unlike glaciers or ice sheets, which are visible and dramatic, permafrost is subtle, lying beneath the surface, stretching for vast distances across the Arctic and high mountain regions. It covers nearly a quarter of the land area of the Northern Hemisphere, reaching from the tundra of Alaska to the expanses of Siberia, from northern Canada to the Tibetan Plateau. On the surface, landscapes above permafrost can appear bleak yet strangely beautiful. The ground is often covered with mosses, lichens, dwarf shrubs, and hardy grasses that can survive the thin active layer, the topsoil that thaws in summer before refreezing in winter. This active layer may only be a few tens of centimetres deep, but it supports ecosystems of reindeer, musk oxen, and Arctic foxes, along with the human communities that have adapted to these extremes. Beneath this living skin, however, lies the permafrost itself, a frozen archive of soil, rock, and ice that has endured through countless winters. What makes permafrost remarkable is not only its sheer extent, but also what it contains. Within its frozen depths lie the remains of long-extinct animals. In Siberia, perfectly preserved mammoths have been unearthed, their flesh still intact, their fur matted but recognizable after tens of thousands of years in the cold. Some specimens are so well preserved that scientists have been able to analyze their DNA, reconstruct their diets, and even imagine, with cautious science, the possibility of de-extinction. Alongside mammoths, other Ice Age creatures such as woolly rhinos and cave lions have been pulled from permafrost, astonishingly intact, as if they had simply been sleeping beneath the ground. It is not only animals that lie hidden. Seeds and plant material locked away for millennia have been coaxed back to life by modern researchers. In one striking case, Russian scientists revived a plant called Silene stenophylla from tissue frozen for over 30,000 years. The plant bloomed and produced seeds as if no time had passed at all. These frozen vaults are not just curiosities but time capsules, preserving a record of ecosystems long vanished. In this sense, permafrost acts as both a freezer and a library, storing fragments of a world otherwise lost to history. Permafrost also contains something far less charming: enormous quantities of organic matter. When plants and animals die in the Arctic, they often do not fully decompose because the cold halts the process. Instead, their remains accumulate in the soil, frozen and preserved. Over tens of thousands of years, this has built up a vast stockpile of carbon-rich material. Estimates suggest that permafrost soils hold more carbon than is currently present in the entire atmosphere. This fact alone makes permafrost one of the most critical elements in the story of climate. The concern arises when permafrost thaws. As temperatures rise, the once frozen organic matter begins to decompose, releasing greenhouse gases such as carbon dioxide and methane into the air. Methane in particular is a powerful gas, many times more effective at trapping heat than carbon dioxide over short timescales. This release creates a feedback loop. Warming causes thawing. Thawing releases gases. The gases cause more warming, and the cycle intensifies. Scientists sometimes refer to this as the permafrost carbon feedback, and it is one of the great uncertainties in predicting future climate change. In some regions, the thawing of permafrost is already reshaping the land. The once solid ground collapses as ice within the soil melts, creating irregular landscapes known as thermokarst. Hills slump, lakes appear where none existed before, and forests tilt into odd angles as their roots lose support, producing the so-called drunken trees of the north. Roads buckle, pipelines fracture, and buildings sink as foundations give way. Communities that have lived on stable frozen ground for centuries are suddenly confronted with a shifting, unreliable surface. The scale of this frozen realm is staggering. In Siberia alone, permafrost underlies an area larger than the entire United States. Across the circumpolar north, it stores nearly twice as much carbon as the atmosphere. Yet despite its importance, permafrost is not uniform. In some places it lies only a metre or two below the surface, while in others it can extend hundreds of metres deep. In certain valleys of Siberia, it has persisted for over 500,000 years, a frozen witness to ice ages and interglacials alike. Beyond carbon, thawing permafrost raises other concerns. Microbes and viruses long dormant may be released. While most will pose no risk, the possibility exists that some ancient pathogens could revive. A notable case occurred in 2016, when a heatwave in northern Siberia thawed permafrost and exposed the carcass of a reindeer infected with anthrax decades earlier. Spores spread, infecting both people and animals. Incidents like this remind us that permafrost does not only preserve the past, it can reintroduce it in unexpected ways. Yet despite these ominous aspects, permafrost landscapes hold a certain austere beauty. In summer, the shallow thaw allows bursts of wildflowers to bloom across tundra plains, creating patches of colour against the muted greens and browns. Herds of caribou migrate across vast distances, guided by instincts honed over millennia. Rivers meander through valleys cut into frozen soils, their banks lined with willows no taller than a person's knee. These places feel timeless, shaped by cycles of freeze and thaw, silence and brief abundance. For the people who call these regions home, permafrost is both challenge and foundation. Indigenous communities in Siberia, Alaska and northern Canada have adapted to its presence for generations, building homes on stilts to avoid the shifting ground, hunting the animals that thrive in its landscapes, and passing down knowledge of how to live with its extremes. For them, permafrost is not simply a scientific concept, but part of daily life, woven into culture and survival. Permafrost also carries a quieter role in Earth's systems. By storing so much frozen water in the soil, it helps maintain regional hydrology, influencing rivers, wetlands, and the delicate balance of Arctic ecosystems. Its thaw reshuffles these systems, draining lakes in some places and creating new ones elsewhere. This continual change makes the Arctic a living laboratory of transformation, where permafrost is both stage and actor. To consider permafrost is to confront the strange duality of ice. It is both a preserver and a disruptor. It has saved mammoths from decay while also threatening to unleash carbon that could accelerate climate change. It sustains tundra ecosystems even as its thaw undermines the ground beneath them. It is frozen yet dynamic, stable yet fragile. When you picture permafrost, do not imagine a lifeless block of ice beneath the soil. Imagine instead a frozen archive, full of history, chemistry, and possibility. Picture the mammoth still resting in its icy tomb, the ancient seed waiting to sprout, the vast store of carbon biding its time. And picture, too, the landscapes above, forests leaning like tipsy dancers, lakes shimmering under a midnight sun, and people whose lives are intertwined with the frozen earth beneath their feet. Permafrost is not as visible as a glacier or as dramatic as a calving ice shelf, but it is no less significant. It is a quiet giant of the frozen world, stretching across continents, holding the memory of past life and the potential to shape the future. In its depths lie both treasures and warnings, both beauty and unease. To understand permafrost is to understand the delicate balance of Earth's climate and the subtle ways that frozen ground can influence the course of life on this planet. A glacier might appear at first glance to be nothing more than a frozen monument, a solid slab of ice resting in a valley. But look closer, or rather, imagine the passage of time not in days but in centuries, and a different picture emerges. Glaciers are not still. They flow ever so slowly, pulled forward by gravity and guided by the land beneath them. They are rivers of ice, sluggish yet relentless, moving masses that shape entire landscapes with their patient persistence. The motion begins deep within the glacier itself. At the surface, ice looks brittle, and indeed, it cracks easily. But under the immense weight of kilometers of snow and ice pressing down, something extraordinary happens. Ice, though solid, can behave like a very viscous fluid when under sustained pressure. Molecules rearrange themselves, sliding past each other, allowing the glacier to deform and creep. This creeping movement is what allows the glacier to flow downhill, following the path of least resistance carved into valleys or spreading outward across plains. In mountain regions, this flow takes on dramatic forms. Imagine a glacier spilling from a cirque, winding its way down a valley like a frozen river. The ice moves fastest in the centre, where it is unimpeded, and slowest at the edges, where it drags against the valley walls. This uneven motion causes stress, and where the stress is too great, the ice fractures into crevasses. These great cracks can plunge tens of meters deep, sometimes wide enough to swallow a bus, their blue interiors glowing with an otherworldly light. Crevasses are reminders that glaciers, for all their smooth surfaces from afar, are under constant tension, always straining and stretching as they inch forward. In steeper terrain, the flow becomes even more spectacular. When a glacier descends a cliff or steep slope, the ice fractures into chaotic blocks, creating what is known as an icefall. These frozen cascades resemble waterfalls turned solid, with seracs, tall, unstable towers of ice, rising like shards in a frozen battlefield. The Khumbu Icefall on Mount Everest is one of the most famous, a labyrinth of crevasses and seracs that climbers must navigate with ladders and ropes. The ice is moving here, constantly shifting, collapsing and reforming. To traverse it is to step into a landscape that seems frozen, but is in truth never at rest. Most of the time, glaciers flow at what seems to us a glacial pace, a phrase that has become a synonym for slowness. A typical valley glacier may advance only a few centimeters to a few meters in a single day. Watch it with the naked eye, and it feels as if nothing changes. Yet measured across seasons, years, or centuries, the transformation is immense. The entire body of ice is on the move, grinding rock beneath it, transporting debris, reshaping valleys. The slow pace is deceptive. The power is real. Every so often, however, glaciers demonstrate that their apparent calm can conceal sudden drama. These are the glacial surges. During a surge, a glacier that normally creeps along at a sluggish rate may suddenly lurch forward at speeds up to 100 times faster than usual. Kilometers of ice may shift in just a few months, overrunning valleys, pushing moraines ahead of them, and leaving landscapes utterly altered. The exact triggers of surges vary. Sometimes it is the build-up of meltwater at the base, sometimes internal shifts in stress, but the effect is unmistakable. A glacier that has spent centuries inching forward suddenly becomes a juggernaut, reminding us of the hidden dynamism within. As they move, glaciers act not only as sculptors but also as transporters. Rocks and boulders trapped in the ice are carried along often for vast distances before being dropped when the ice melts. Entire fields of erratics, giant stones stranded far from their source, are the result of this journey. The ice carries its cargo silently, a slow procession of rock that eventually shapes the character of the land. Beneath the glacier, meanwhile, the bedrock is ground into fine powder called glacial flour, which rivers wash downstream, turning lakes and streams a striking turquoise colour. The flowing ice thus acts as both destroyer and creator, carving mountains even as it paints lakes with surreal colours. There is a curious paradox in the nature of glacial motion. On the one hand, glaciers embody slowness. They creep so gradually that human lifespans hardly register their progress. On the other hand, their power is immense. They can carve valleys kilometres wide, move mountains of rock and alter coastlines. The combination of slow patience and overwhelming force makes them unique among Earth's natural processes. Rivers may roar, volcanoes may explode, but glaciers achieve their transformations quietly, steadily, and with unmatched persistence. This balance of stillness and power also shapes how we perceive them. From a distance, a glacier may look peaceful, a gleaming tongue of white nestled among mountains. Up close, the creaking and cracking of shifting ice remind us that it is alive with movement. Spend enough time near one, and you may hear sudden groans as stresses release, or witness ice collapsing into a crevasse with a muffled thud. These are the voices of a river that speaks in the language of pressure and fracture, a dialogue between gravity and frozen water. The sheer scale of glacial flow is difficult to comprehend without stepping back in time. Over the course of an ice age, glaciers have advanced across continents, covering thousands of kilometres. The Laurentide ice sheet, for example, once sprawled over North America, its ice flowing southward and sculpting the Great Lakes. The lakes themselves are remnants of this flow, basins gouged by ice and filled with meltwater. What we see as familiar landscapes today are simply pauses in the longer motion of glaciers, frozen rivers that have come and gone over cycles stretching hundreds of thousands of years. To imagine this motion, picture a slow dance between rock and ice. The glacier pushes forward, carving into the mountain. The mountain resists, rising anew through tectonic uplift. Over eons the dance continues, a contest that has no winner, only change. The valleys of the Alps, the fjords of Norway, the Great Plains of Canada, all are steps in this choreography, recorded in stone and water. It is easy to think of glaciers as relics of a colder past, but they remain dynamic today. In the Himalayas, in Patagonia, in Alaska, and in Greenland, glaciers still slide down valleys, their surfaces fractured with crevasses, their bases lubricated with meltwater. Satellite imagery captures their slow retreat in many regions, yet even as they shrink, their movement continues. They do not freeze into stillness, they flow until their very end. There is a quiet lesson in the patience of glaciers. They remind us that movement need not be fast to be transformative, that progress measured in centimetres can, over time, carve worlds, that what appears silent and still may be teeming with hidden dynamism. The rivers of ice show us that time is a sculptor more powerful than any sudden force, and that change, though slow, is inevitable. Standing before a glacier, Whether in the shadow of an icefall or at the edge of a crevasse, one feels the weight of this lesson. The ice stretches away, moving but unhurried, ancient but alive. It is both fragile and unstoppable, a paradox made solid, and as it continues its slow journey down valleys and toward the sea, it carries with it the story of patience, persistence, and the immense power hidden within quiet motion. Ice is not only a sculptor of landscapes, but also a quiet regulator of the planet's climate. Though it seems passive, a frozen reservoir of water simply waiting for the sun, ice exerts enormous influence over Earth's temperature and atmosphere. From reflecting sunlight back into space, to locking away greenhouse gases, to driving the rhythms of glacial cycles, ice acts as one of the great moderators of the global system. Without it, the Earth would be a very different and far warmer place. One of the most important ways ice interacts with climate is through reflectivity, known as the albedo effect. Albedo is a measure of how much light a surface reflects rather than absorbs. Fresh snow has an exceptionally high albedo, bouncing back as much as 90% of incoming sunlight. Even older, compacted ice reflects a large portion of energy. Compare this with a dark forest, which reflects only about 10 to 15%, or the ocean, which absorbs most of what falls upon it. The difference is profound. When ice covers vast areas, the planet sends a great deal of solar energy back into space, keeping temperatures lower. This creates a feedback loop. When temperatures drop and ice expands, albedo increases, reflecting more sunlight, which cools the Earth further, allowing ice to spread. Conversely, when ice melts, darker ground or water is exposed, absorbing more heat, which accelerates melting. These feedbacks help explain why the poles warm faster than the global average. The loss of reflective ice is like swapping a mirror for a sponge. The planet suddenly soaks up more energy, tilting the balance toward warming. The albedo effect is not a small influence. It is central to the planet's climate stability. During the Great Ice Ages, when glaciers covered much of North America and Europe, Earth was significantly cooler, in part because so much light was being reflected away. Today, as ice retreats in Greenland, Antarctica and the Arctic Ocean, the reverse is happening. Sea ice loss in particular has a magnified effect, since it exposes dark seawater that absorbs heat and further disrupts polar climates. But ice's role does not stop with reflectivity. It also participates in the grand cycles of glaciation and interglaciation, those alternating cold and warm periods that have defined the past few million years. These cycles are paced by subtle changes in Earth's orbit and tilt, known as Milankovitch cycles. Small shifts in how the planet wobbles, how elliptical its orbit becomes, and how it tilts toward the sun can alter the distribution of sunlight across latitudes. On their own, these orbital variations would not be enough to cause massive ice sheets to advance and retreat. But with the feedback of ice itself, the effects are amplified. When orbital changes tilt the planet toward cooler summers in the northern hemisphere, snow persists longer, ice accumulates, reflecting more sunlight, and temperatures drop further. As the ice sheets grow, they lower sea levels, alter ocean currents, and change atmospheric circulation. When orbital shifts move the other way, summers become warmer, ice melts, albedo decreases, and the planet warms. These cycles explain the rhythm of ice ages, vast swings in climate written into the geological record. Ice does not merely respond to climate, it magnifies it, guiding the pace of Earth's great temperature swings. Within glaciers and ice sheets, another quiet process is at work, the trapping of greenhouse gases. As snow falls and compresses into ice, tiny bubbles of air are sealed within. These bubbles are time capsules, holding ancient atmospheres. Scientists drilling into Greenland and Antarctic ice cores have extracted air that is hundreds of thousands of years old. From these samples, we know how much carbon dioxide, methane, and other gases filled the air at different times in history. The record shows a striking pattern. During glacial periods, greenhouse gas levels were lower, During warmer interglacials, they were higher. Ice, in essence, archives the breath of the planet. But ice is not only a passive recorder of gases. By locking carbon-rich materials in permafrost and beneath ice sheets, frozen environments also prevent greenhouse gases from entering the air. Organic matter frozen in soils cannot decay fully, meaning the carbon remains stored. During ice ages, expanded permafrost locked away even more. This storage function is enormous in scale, rivaling other global carbon reservoirs. As long as the ice remains, much of this material is kept out of circulation. Of course, this also means that melting ice has the potential to release vast amounts of carbon and methane. Permafrost thaw, as already seen in Siberia and Alaska, is beginning to free organic matter that decomposes and emits gases. The concern is that this release could reinforce warming, a feedback loop that amplifies the very process that caused it. In this way, the fate of ice is deeply tied to the trajectory of the climate. The relationship between ice and climate is not limited to chemistry and physics. It also extends to circulation systems. Meltwater from ice sheets can alter ocean currents by changing the salinity of seawater. During the last ice age, sudden floods of meltwater are believed to have disrupted the Atlantic meridional overturning circulation, a conveyor belt of ocean currents that transports heat around the globe. Such disruptions may explain abrupt climate shift recorded in ice cores and sediments, where temperatures in Greenland jumped or fell by several degrees within decades. Ice, once again, proves capable of influencing global systems in far-reaching ways. The complexity of these interactions makes ice one of the most fascinating players in the climate system. It is not simply frozen water, inert and waiting to melt. It is an active component, capable of cooling the planet, storing its past and shaping its future. Its presence stabilizes, its retreat destabilizes. When we imagine climate change, we often picture rising seas or hotter summers, but at the root of these shifts lies the behavior of ice. There is a poetic quality in the way ice balances extremes. It tempers heat by reflecting light. It moderates gases by storing them in frozen vaults. It paces the heartbeat of the earth through glacial rhythms. And yet, when disturbed, it can magnify change, speeding warming, releasing carbon, and altering oceans. Ice is both a guardian and a trigger, a stabilizer and a potential catalyst. To stand on a glacier or gaze across an ice sheet is therefore to see more than frozen water. It is to see one of the planet's great control systems, operating slowly, quietly, but profoundly. The whiteness before you is a mirror to the sun. The layers beneath your feet are pages of atmospheric history. The meltwater streams trickling away are hints of vast processes that stretch across the globe. Ice and climate are bound together in a partnership as old as Earth's cold phases. Each shapes the other, each responds to the other, each amplifies the other's changes. Their dance has written the story of ice ages and interglacials, of frozen epochs and warm intervals. It continues today, only now with the added influence of human activity tipping the balance. As we look at the frozen parts of our world, we are not just admiring scenery but witnessing one of the planet's most powerful regulators at work. Ice is climate made visible, climate you can touch, climate you can hear creaking and cracking as glaciers move. Its presence cools us, its retreat warns us, and its cycles remind us that Earth's climate has never been static. Ice is both history and prophecy, an archive of the past and a signpost pointing toward possible futures. At first glance, glaciers and frozen landscapes appear barren, lifeless, and utterly inhospitable. To the casual observer, they are blank slates of white and blue, dominated by silence and cold. Yet beneath the surface, within the ice and around its edges, lies a surprising abundance of life. From microbes thriving in darkness to animals perfectly tuned to endure extreme cold, and even humans carving out survival against the odds, the frozen realm is anything but empty. It is, in its own way, a vibrant ecosystem that has found ways to flourish in conditions that seem impossible. Begin with the smallest inhabitants, the microbes. Deep beneath glaciers, where light never reaches and temperatures remain below freezing, microbial communities have adapted to survive. They feed not on sunlight but on minerals and chemical reactions, eking out energy from the tiniest of resources. In subglacial lakes such as Lake Vostok in Antarctica, sealed beneath kilometers of ice for millions of years, scientists have discovered microbial DNA, evidence that life persists even in such isolated, pressurized and oxygen-poor environments. These organisms rewrite our understanding of where life can exist. If bacteria can survive in the dark belly of a glacier, it suggests that frozen worlds elsewhere in the solar system, places like Europa or Enceladus, might also harbour life. On the surface of ice itself, strange organisms make their homes. Algae bloom in summer, staining snow with hues of red or green, sometimes called watermelon snow. These algae not only survive but actively grow in conditions where water exists only briefly, adapting to ultraviolet radiation with protective pigments. Tiny rotifers and tardigrades, microscopic animals known for their resilience, can also be found in icy films of meltwater. The frozen world is thus not sterile but teeming with small, hardy forms of life invisible until one looks closely. Moving up the scale, the frozen realm is home to some of Earth's most iconic creatures. Consider the polar bear, master of the Arctic sea ice. Its thick fur and layer of blubber insulate it against the cold, while its keen sense of smell allows it to locate seals beneath the snow. These bears are so attuned to their frozen environment that their very survival depends on the seasonal rhythm of sea ice, which provides their hunting grounds. In the Antarctic, penguins fulfill a similar role as emblematic inhabitants of ice. Emperor penguins huddle together in the darkness of polar winter, sharing warmth in giant groups while the males incubate eggs for months without food. Marine mammals also thrive in icy waters. Seals haul out on floes to rest and rear their young, walruses crowd onto beaches and ice edges, and whales migrate through frigid seas rich with krill. Narwhals, with their long spiral tusks, dive deep beneath the ice to hunt fish in Arctic waters. Beluga whales, pale as the ice itself, navigate through leads and cracks in frozen seas. These animals are not merely surviving, but thriving in environments where humans would perish without heavy protection. Birds, too, have made these cold places their homes. Arctic terns undertake the longest migration of any animal, travelling from Arctic breeding grounds all the way to the Antarctic and back each year, essentially chasing endless summer. Snowy owls, with their white plumage, blend seamlessly into tundra landscapes, hunting lemmings that scurry beneath the snow. The diversity of life in these cold regions is a reminder that even the most extreme climates can support abundance, provided species adapt in ingenious ways. For humans, the frozen world has always been a challenge, but one that many cultures have risen to meet. Indigenous peoples of the Arctic, the Inuit, the Sami, the Chukchi, the Nenets, and many others, have lived in permafrost landscapes for thousands of years. They developed extraordinary resilience and ingenuity, crafting clothing from animal skins and furs that could withstand brutal cold, building shelters that trapped heat efficiently, and relying on hunting and fishing to sustain communities where agriculture was impossible. Their knowledge of the land, the ice, and the animals that inhabit it is profound, passed down through generations as a survival manual written in lived experience. Traditional tools such as dog sleds, kayaks, and snowshoes demonstrate how humans adapted technology to suit frozen environments. Clothing tailored from caribou hides or sealskins provided insulation superior to many modern materials. Spiritual traditions often reflect respect for the land and its creatures, recognizing the precarious balance of survival in such an unforgiving climate. Life in these regions has never been easy, but it has been rich, shaped by a deep connection to the rhythms of ice and snow. Even today, communities live on the edge of permafrost, balancing tradition and modernity. Towns in Alaska, Siberia, and northern Canada face unique challenges as thawing permafrost shifts the ground, undermines infrastructure, and alters hunting patterns. Yet people endure, showing that human adaptability extends even to the harshest corners of the planet. Scientists and explorers also spend months in research stations across Antarctica, braving the cold to unlock secrets of climate and life. They rely on layers of technology, insulated bases, snow tractors, and constant supply chains to survive where ancient cultures could not. The frozen realm has also provided humans with resources and inspiration. Ice itself has been used to preserve food, and glaciers have been tapped for fresh water. But beyond utility, ice has sparked imagination. From myths of frost giants to stories of endless winters, cultures across the world have woven the frozen landscape into their storytelling. Even today, icy wildernesses inspire awe in travellers who venture into fjords or across tundra, marvelling at the persistence of life in such extremes. One of the most remarkable aspects of life in frozen regions is the constant interplay between hardship and resilience. Microbes adapt to conditions that would kill most organisms instantly. Animals evolve specialised behaviours, from the emperor penguin's cooperative huddling to the polar bear's efficient hunting, that allow them to flourish where food is scarce and cold is unrelenting. Humans learn to read snow, to follow the migrations of animals, and to engineer ways of surviving the cold's assault. Life does not merely endure in the frozen realm, it adapts creatively, turning apparent disadvantages into strategies for survival. There is also an elegance to these adaptations. The thick fur of an Arctic fox that changes colour with the seasons, the antifreeze proteins in the blood of certain fish that prevent ice crystals from forming, the navigation skills of migratory birds using the stars and Earth's magnetic field. Each is a marvel of evolution. The frozen world is a showcase of ingenuity, where nature demonstrates its capacity for innovation under constraint. At the same time, these ecosystems are fragile. Many of the species that depend on ice are vulnerable to its loss. Polar bears rely on sea ice to hunt. Without it, they struggle. Walruses and seals need stable ice edges. Without them, they are forced into overcrowded conditions. Indigenous communities whose knowledge is tied to ice and snow face uncertain futures as permafrost thaws and animals shift their ranges. The frozen realm is not static but deeply tied to the rhythms of climate, and as those rhythms change, so too does life at the edge of cold. To reflect on life in frozen landscapes is to appreciate not only its strangeness, but also its richness. From the tiniest microbes feeding in darkness beneath glaciers to the largest whales navigating through icy seas, from the penguin huddled against a storm to the hunter guiding a sled across snow, the frozen realm is alive with stories of endurance. It may look silent and still, but listen closely, and you will hear the quiet hum of ecosystems adapted to thrive where others could not. In the end, the frozen realm is a paradox, forbidding yet full of life, harsh yet home, desolate yet deeply alive. It shows that life's creativity knows no bounds, reaching even into the coldest corners of our planet. And in its endurance, it reminds us that survival is not always about conquering the environment, but about learning to live in harmony with its challenges. For as long as people have walked the earth, ice has been both a barrier and a guide, a source of fear and wonder, a canvas on which myths and memories were written. The story of humanity is intertwined with frozen landscapes, not as a backdrop but as a shaping force that influenced where people could live, how they moved, and even how they understood the world around them. During the last great ice age, which reached its peak around 20,000 years ago, vast ice sheets stretched over North America, Northern Europe, and large parts of Asia. Whole regions were rendered uninhabitable beneath kilometres of frozen weight. Yet the same ice age also made human migration possible. As the seas retreated, their waters locked in ice, land bridges appeared. The most famous of these is Beringia, the bridge of land that once connected Siberia to Alaska. Across this frozen corridor, humans and animals alike moved between continents, shaping the genetic and cultural story of peoples across the Americas. Without the Ice Age, The pathways of migration would have been different, and human history as we know it might never have unfolded in the same way. The glacial landscapes themselves left lasting marks on early societies. Meltwater carved fertile valleys, deposited rich soils, and filled basins with freshwater lakes. These became natural homes for agriculture thousands of years later. The very ground on which some of the first civilizations arose was a gift from the retreat of glaciers. The legacy of ice was not just in what it froze, but in what it left behind. In human imagination, ice often held a symbolic role. In Norse mythology, the world itself was born from the meeting of fire and ice. From the frozen void of Niflheim and the fiery realm of Muspelheim came the first beings, shaped in the collision of extremes. This duality, ice as both destructive and creative, echoes the very real experience of glaciers, which can erase a landscape while simultaneously crafting new forms of beauty. For northern peoples, frozen worlds were not lifeless, but part of the cosmic order, woven into creation stories that gave meaning to the cold they endured. Other traditions treated ice as a force of terror. In ancient Greece, descriptions of lands beyond the north spoke of Hyperborea, a mysterious frozen place at the edge of the world, unreachable and eternal. In many cultures, ice was imagined as the frontier of existence, where humans could not survive and where gods or spirits held sway. The shimmering lights of the aurora dancing over icy horizons were seen as omens, messages from ancestors or warnings from unseen realms. Yet ice was not always an adversary in these stories. It could also be a source of purity, clarity, and renewal. In some Asian traditions, the frozen peaks of mountains were sacred, their ice regarded as the dwelling place of deities. Meltwater flowing from glaciers was seen as holy, carrying the blessings of the high places down to the valleys below. In Tibet and the Himalayas, glaciers have long been revered, their presence tied to the lifeblood of rivers such as the Ganges and the Indus. For ancient travellers, encounters with glaciers were rare and often bewildering. Imagine a merchant or pilgrim crossing the Alps in Roman times, confronted by fields of crevassed ice stretching into the distance. To eyes unaccustomed to such landscapes, glaciers must have seemed otherworldly, rivers made solid, alive with eerie groans and sudden collapses. Roman writers describe these frozen places with awe and apprehension, sensing both danger and grandeur. Later, in medieval Europe, glaciers advancing during the so-called Little Ice Age swallowed farms and villages, creeping down valleys and forcing people to abandon homes. Priests led processions to bless the ice, hoping to halt its advance with prayer. By the Enlightenment, glaciers began to shift from being purely feared to being studied. Natural philosophers in the 17th and 18th centuries ventured into icy regions with notebooks and curiosity. They began to measure, to sketch, and to wonder about the strange movement of frozen rivers. It was in these centuries that glaciers transformed in the European imagination, from devouring monsters to fascinating natural phenomena. Romantic poets and painters later embraced them as symbols of the sublime, overwhelming, terrifying, and yet profoundly beautiful. Turner and Caspar David Friedrich painted icy landscapes not merely as scenery, but as metaphors for human fragility against the vastness of nature. Meanwhile, in other parts of the world, people continued to live alongside glaciers in a more practical relationship. In the Andes, communities drew water from glacial melt to irrigate crops, creating ingenious systems that depended on the seasonal rhythm of ice. In the Himalayas, villagers built ice stupas, cone-shaped ice reservoirs designed to store winter water for summer use, blending engineering with cultural symbolism. These encounters reveal that glaciers were never only obstacles but also resources, lifelines woven into human survival. In modern times, glaciers became destinations of exploration and adventure. The great age of mountaineering in the 19th century saw climbers ascending peaks like Mont Blanc and the Matterhorn, crossing glaciers with ropes and primitive equipment. For them, The ice represented both a challenge and a path, a place to test endurance and courage. Scientists too deepened their investigations, realizing that glaciers held not just beauty, but also records of past climates. The drilling of ice cores in Greenland and Antarctica has since given us one of the clearest windows into Earth's atmospheric history, stretching back hundreds of thousands of years. Today our encounters with glaciers are tinged with urgency. Tourists flock to see them, marvelling at their size and brilliance, even as many are shrinking before our eyes. Villages that once depended on predictable meltwater now face uncertainty as glaciers retreat. Myths of advancing ice have given way to anxieties about vanishing ice. The cultural symbolism of glaciers is shifting once again, from forces of awe and fear to emblems of fragility, reminders of the delicate balance we're disturbing. Still, the human story of ice remains one of deep connection. From the migrations enabled by frozen land bridges, to the myths that imagined the cosmos born of ice, to the scientists who chip away at its secrets with drills and sensors, ice has always been more than frozen water. It's been a partner, an adversary, a teacher, and a warning. It has shaped not only the land beneath our feet, but also the stories we tell about our place in the world. To think of our history without ice is impossible. It guided our ancestors across continents, inspired creation myths and art, tested our ingenuity, and now calls us to pay attention as it changes once more. Ice is woven into our migrations, our imaginations, and our futures. It is a reminder that even the coldest, most silent parts of the Earth have always been deeply entangled with the human journey. Deep within the frozen heart of Greenland and Antarctica, a remarkable library lies buried. It is not filled with books or scrolls, nor written in ink, yet it contains one of the most complete records of Earth's climate ever discovered. This archive is stored in ice, preserved layer by layer over hundreds of thousands of years. To scientists, drilling into it is like opening a diary of the planet's past, each page written in frost, each bubble a message from a time long gone. These ice cores, slender cylinders pulled from deep within glaciers and ice sheets, have transformed our understanding of how the Earth's climate has shifted through ages of warmth and cold. The principle is simple yet profound. Each year, snowfall blankets the ice sheets. In summer, the snow may compact, but it does not melt away. Over time, these seasonal layers are compressed by the weight of new snow above, gradually transforming into dense ice. Within this ice, tiny bubbles of air become trapped, sealed away from the atmosphere. These bubbles are nothing less than time capsules, miniature pockets of the air as it was when the snow first fell. When a scientist retrieves an ice core, they are holding in their hands the atmosphere of centuries, even millennia, past. The information stored is astonishingly detailed. Ratios of oxygen isotopes in the ice itself reveal past temperatures, allowing researchers to reconstruct climate variations year by year. The air bubbles contain greenhouse gases such as carbon dioxide and methane, providing direct measurements of their concentration in ancient times. Dust trapped in the layers shows volcanic eruptions or winds carrying sand from distant deserts. Even traces of sea salt, pollen, or cosmic particles can be detected, offering insights into storms, ocean conditions, and even solar activity. Each ice core is therefore a multifaceted record, capturing not just climate but the interconnected web of Earth systems. The drilling of ice cores is no small feat. In Antarctica, teams endure months of darkness, storms, and temperatures colder than -40°C to reach drilling sites. The machinery must bore through kilometers of ice, extracting cylinders only a few centimeters wide but several meters long. These cores are carefully logged, catalogued, and shipped under frozen conditions to laboratories, where they are analysed with extraordinary precision. The patience required mirrors the patience of the ice itself, which has accumulated its record grain by grain over hundreds of thousands of years. Some of the most significant cores have come from Greenland. The Greenland Ice Sheet Project, known as GISP, and later the Greenland Ice Core Project, GRIP, revealed climate swings of startling rapidity. Layers in Greenland's ice showed that temperatures in the North Atlantic region had jumped by several degrees within only a few decades, evidence of abrupt climate change. These findings shattered the older assumption that climate shifts always unfolded slowly and steadily. Instead, they demonstrated that the Earth's climate system is capable of dramatic and sudden swings, a revelation that reshaped the field of climate science. Antarctica, too, has offered revelations. The European Project for Ice Coring in Antarctica, or EPICA, drilled a core nearly 3 kilometres deep at Dome Sea. From it came an uninterrupted climate record stretching back 800,000 years. This core revealed the pacing of ice ages and interglacials with exquisite clarity. Carbon dioxide concentrations rose and fell in step with temperatures, confirming the intimate link between greenhouse gases and climate. For the first time, scientists could trace the rhythm of Earth's glacial cycles across almost 1 million years, seeing patterns in astonishing detail. These discoveries have not only illuminated the past, but also sharpened our understanding of the present. By comparing ancient gas concentrations with modern measurements, researchers have shown how unusual current levels are. The carbon dioxide concentration in today's atmosphere exceeds anything seen in those 800,000 years of Antarctic ice, and it is rising at a pace far faster than natural fluctuations. Ice cores thus provide a sobering perspective. Our current trajectory is not simply part of a natural cycle, but something unprecedented in recent geological history. Ice cores also reveal the fingerprints of specific events, layers marked with spikes of sulfate, record massive volcanic eruptions such as Krakatoa in 1883 or Tambora in 1815, events that cooled the planet for years by shrouding it in ash and aerosols, traces of nuclear fallout from mid-20th century weapons testing appear as sharp chemical markers in the upper layers, a reminder of humanity's more recent imprint. These signals are like annotations in the icy archive, helping to align natural history with human history. What makes this frozen archive especially striking is its clarity. Unlike sediments in lakes or ocean floors, which can blur and smear signals, ice preserves its layers with exquisite sharpness. A core can often be counted like tree rings year by year, revealing annual cycles of snowfall and dust. Some Greenland cores allow reconstructions at seasonal resolution, capturing not just centuries but the very rhythm of years long past. To hold such a record is to collapse time, to bring into the present the breath of mammoths, the smoke of ancient fires, and the air of worlds before our own. And yet, ice cores are more than scientific instruments. They hold a certain poetry. Imagine peering into a bubble of air trapped 500,000 years ago. That tiny pocket contains the breath of forests that no longer exist, the exhalations of creatures long extinct, the trace of winds that blew across forgotten seas. It is as if the ice has kept a secret, patiently waiting for us to discover it. The frozen memory of Earth speaks softly but clearly, telling us of cycles, upheavals, and the delicate balance that sustains life. There's also something humbling about the effort required to retrieve these records. Researchers endure isolation, blizzards, and months of hardship to bore through the ice, knowing that each meter drilled is another step into the past. When the core finally emerges, glistening in the polar sun, it carries with it not only data but a sense of awe. The knowledge that within this slender cylinder lies the story of Earth's atmosphere is enough to quiet even the most restless mind. The importance of these icy archives extends far beyond the poles. They anchor climate models, guide our predictions, and provide context for the challenges we now face. Without them, our understanding of climate would be blurred, based only on indirect proxies. With them, we can see the dance of carbon and temperature across ages, the sudden shocks of rapid shifts, and the extraordinary stability of recent millennia. Stability that allowed human civilization to flourish. In essence, ice cores remind us that the climate is not static but a living, breathing system. They show that warmth and cold have waxed and waned, that gases and temperatures have risen and fallen together, that change is inevitable but also variable in pace and scale. They highlight the extraordinary uniqueness of the present, a moment when our actions are pushing the system faster than ice can record. To hold an ice core is to cradle the memory of Earth, preserved not in stone but in frozen water. It is an archive written not by human hands but by the planet itself, an autobiography inscribed with snowflakes and sealed in time. Each bubble, each layer, each trace of dust whispers part of the story, and taken together they remind us that the Earth has always been in motion, always shifting, always writing and rewriting its history in ice. Across the world, from the jagged peaks of the Andes to the icy plateaus of the Himalayas, glaciers are in retreat. Their tongues, once stretching proudly down valleys, are pulling back. Their surfaces, once gleaming expanses of white, are darkening with meltwater streams and soot. In photographs separated by just a few decades, the difference is often startling. A once massive glacier reduced to a fraction of its size, its former extent marked only by barren rock and freshly exposed soil. This global retreat is not an isolated phenomenon, but a pattern repeated across continents, a visible sign of a changing climate written into the landscape. The evidence comes from many places. In the European Alps, glaciers that once inspired romantic painters and early mountaineers have shrunk dramatically. The Rhone Glacier in Switzerland, which tourists visited in the 19th century to marvel at its icy grottos, has retreated so far that protective blankets are now spread over parts of it each summer in an attempt to slow its melt. In Glacier National Park in Montana, many of the park's namesake glaciers have nearly vanished, with some reduced to little more than snowfields. Where there were once over 150 glaciers at the end of the 19th century, today fewer than 30 remain large enough to be officially counted. The Himalayas, sometimes called the Water Towers of Asia, tell a similar story. Here, thousands of glaciers feed rivers such as the Ganges, the Indus, and the Brahmaputra, sustaining hundreds of millions of people downstream. Yet satellite images show that many of these glaciers are retreating rapidly, their melt lakes expanding and threatening sudden floods. The loss of ice here is not only a question of beauty or wilderness, but of water security for vast populations. In South America, the tropical glaciers of the Andes are retreating at alarming rates. Peru's Quelcaya ice cap, the largest tropical ice body in the world, has been shrinking steadily for decades. Farmers in surrounding regions have relied on its meltwater to irrigate crops and sustain livestock. But as the ice retreats, dry seasons grow harsher. In Bolivia, the Chacaltaya Glacier, once home to the world's highest ski resort, disappeared completely in 2009, melting decades earlier than scientists had predicted. Even the giants of the frozen world, Greenland and Antarctica, show signs of change. While their vast interiors remain frigid, the edges are thinning, and glaciers that drain their ice sheets are accelerating toward the sea. Jakobshavn Glacier in Greenland, once the fastest flowing glacier on Earth, has retreated tens of kilometers in the past century. In West Antarctica, the Pine Island and Thwaites glaciers have been losing ice at accelerating rates, prompting concern about long-term sea level rise. The sheer scale of these systems makes their retreat difficult to comprehend, but the evidence is undeniable. The impacts ripple outward in profound ways. For communities near mountain glaciers, meltwater is a lifeline. In many regions, glaciers act as natural reservoirs, storing snow and ice in winter and releasing water slowly in summer. This flow sustains rivers during dry months, feeding farms, cities, and ecosystems alike. As glaciers shrink, their ability to provide this steady flow diminishes. At first, there may be a temporary increase in water as melting accelerates, but once the glacier is significantly reduced, the supply dwindles. For farmers in the Andes or herders in the Himalayas, this change can mean the difference between abundance and hardship. Ecosystems also depend on the rhythm of glacial melt. Cold, nutrient-rich waters flow from glaciers into streams and lakes, supporting fish, and other aquatic life. As glaciers retreat, these systems warm, altering habitats. Salmon runs in Alaska, for example, are influenced by the temperature and flow of rivers fed by glaciers. As those rivers change, so too does the delicate balance of life that relies on them. Even in the seemingly barren landscapes left behind by retreating glaciers, new ecosystems emerge. Pioneer plants colonize freshly exposed rock, lichens spread, and eventually grasses and shrubs take hold. Over centuries, forests may grow where ice once lay. Retreat is not the end of life, but the beginning of a different chapter. There is a quiet poignancy in watching a glacier retreat. These rivers of ice, which once advanced with patient persistence, now slip back with unusual haste. Villages that once sat in the shadow of a glacier now look up at bare stone. Tourists visiting iconic sites such as Alaska's Mendenhall Glacier or New Zealand's Franz Josef Glacier find themselves walking longer and longer trails just to reach the ice, which once extended almost to the roadside. For those who have lived their lives beside glaciers, the change is personal, a reminder of the speed with which the world can transform. Yet glaciers are more than symbols of loss. Their retreat tells us something essential about the climate system. Ice is sensitive to temperature, responding with clarity to shifts that might otherwise be hidden. While a degree or two of warming may seem trivial in daily life, to a glacier it is decisive, the difference between growth and retreat. In this sense, glaciers are sentinels, visible markers that record the pulse of a warming world. Their shrinking edges are like the receding ink of a letter, spelling out a warning in the landscape itself. The cultural response to retreating glaciers is varied. In some regions there are ceremonies held to honour the ice, to thank it for its gifts of water, and to mourn its disappearance. In the Andes, rituals known as pagos a la tierra, offerings to the earth, are performed to show respect for mountains and glaciers as living entities. In Europe, scientists and artists alike have staged symbolic funerals for glaciers, laying plaques to mark their passing. These acts reflect the recognition that glaciers are not just physical features, but also part of human identity and memory. And still, for all the melancholy attached to their retreat, glaciers remind us of resilience and change. They have advanced and retreated countless times in Earth's history, responding to natural cycles of orbit, atmosphere, and ocean. What makes the present moment unusual is the speed and the cause. The current retreat is not driven by slow, natural rhythms, but by rapid human-induced warming. In just a century, glaciers have shrunk at rates that would normally take millennia. This acceleration underscores how tightly our actions are now woven into the fate of ice. To reflect on retreating glaciers is to hold two truths at once, a recognition of loss and an appreciation of transformation. The landscapes they leave behind are scarred yet fertile, empty yet full of possibility. Their disappearance is a warning of changes unfolding across the globe, but it is also a reminder of the constant flux that has always defined the Earth. The silence of a glacier pulling back into its valley is both an ending and a beginning. When you stand before the snout of a retreating glacier, you witness more than melting ice. You see centuries collapsing into moments, patience overtaken by haste, and the intimate link between climate and landscape made visible. You see the fragility of what once seemed eternal, and the quiet message it leaves behind. Nothing, not even the mightiest river of ice, remains unchanged forever. The seas at the very top and bottom of the world carry a secret. In winter they harden, transforming into vast white landscapes where water takes on the solidity of stone. Unlike glaciers or ice sheets that rest firmly on land, this ice floats, drifting with tides and currents, cracking and reforming with the seasons. Known as sea ice, it is one of the most dynamic and fragile forms of frozen water on Earth. Understanding it means drawing a clear distinction between ice that floats and ice that rests upon land, because though they may look similar from afar, their roles in shaping our planet are profoundly different. Sea ice forms when the surface of the ocean freezes. Salt water resists freezing more than fresh water, so it takes temperatures well below 0 degrees Celsius for the process to begin. When it does, tiny crystals appear, clustering into thin sheets that spread across the surface. Over time, these sheets thicken, sometimes to several meters, until they form continuous ice flows. In the Arctic Ocean, much of the sea ice survives through the summer, piling into multi-year slabs that can be ridged and hummocked by pressure. In Antarctica, sea ice tends to be thinner and more seasonal, spreading out in winter to an area nearly as large as the African continent before shrinking back each summer. Land ice, by contrast, originates on solid ground. It comes from snow compacted into glaciers and ice sheets, such as those covering Greenland and Antarctica. When land ice melts or calves into the sea, it adds new water to the ocean, raising sea levels. Sea ice does not have this effect. Because it already floats, its melting does not directly raise the seas, just as an ice cube in a glass of water does not cause the level to rise when it melts. Instead, sea ice influences the planet in other ways, most importantly by regulating climate and creating unique ecosystems. The reflective quality of sea ice is one of its defining traits. Bright and white, it sends much of the sun's energy back into space. When it disappears, darker ocean water is revealed, absorbing heat and amplifying warming. This makes sea ice a vital regulator of Earth's temperature. Its seasonal growth and retreat are like a breathing rhythm for the polar regions, and any disruption to this rhythm resonates across the globe. Sea ice also acts as a foundation for life. Beneath it, algae grow in briny channels within the ice, nourished by the faint light filtering through. These microscopic plants are the base of a food web that supports krill, fish, seals, whales, and countless seabirds. In the Arctic, polar bears rely on sea ice as hunting platforms, waiting at breathing holes to catch seals. Without ice, they must swim longer distances or scavenge on land, a less reliable strategy. In the Antarctic, penguins, particularly Adelie and emperor penguins, depend on sea ice for breeding grounds and for access to krill, which thrive in icy waters. Remove the ice, and entire ecosystems lose their foundation. Consider the polar bear. Its very existence is tied to frozen seas. These animals are powerful swimmers, but they cannot live in the ocean indefinitely. They need ice flows as resting points, as hunting blinds, and as nurseries for raising young. In recent decades, shrinking Arctic sea ice has forced polar bears into tighter spaces, reducing their hunting success and pushing some populations into decline. The image of a bear stranded on a solitary ice floe has become a potent symbol of environmental change, not only because it tugs at human sympathy, but because it illustrates how closely life can be bound to frozen water. On the opposite side of the globe, penguins play an equally iconic role. Emperor penguins breed on stable sea ice, enduring the coldest winter temperatures on Earth, while huddling together for warmth. If the ice forms too late or breaks too soon, entire colonies can fail. Krill, the tiny crustaceans that underpin the Antarctic food chain, depend on algae growing beneath sea ice. Remove the ice, and krill populations diminish, rippling upward to affect fish, whales, and seabirds. The connections are intricate, but they all come back to one fragile layer of frozen ocean. Humans, too, have long adapted to frozen seas. Indigenous communities in the Arctic have used sea ice as highways for hunting and travel, reading its patterns with remarkable skill. The thickness of floes, the sound of cracks, the tilt of ridges, all are signs that guide safe passage across a shifting living surface. Sea ice has also shaped exploration and history. For centuries, European explorers searching for a northwest passage were stymied by impenetrable ice, their ships trapped and crushed. Only in recent years, as summer ice shrinks, has the passage opened more reliably, a development both celebrated for trade and lamented for what it reveals about warming. Trends in recent decades show a clear pattern. Sea ice is shrinking, thinning, and becoming less stable. In the Arctic, the summer minimum extent has declined by more than 40% since satellite records began in the late 1970s. Multi-year ice, once the backbone of the Arctic pack, is rapidly being replaced by thinner seasonal ice that melts more easily each summer. In Antarctica, the pattern is more complex, with regional variations, but even there, record lows in sea ice extent have been observed in recent years. The loss of ice affects not only local ecosystems, but also weather patterns far beyond the poles. The changes ripple outward in unexpected ways. As sea ice diminishes, open waters allow larger waves to build, eroding coastlines that were once shielded by ice cover. Warmer oceans, freed of their icy lids, release more heat and moisture into the atmosphere, altering storm tracks. The reduction of Arctic sea ice has been linked by some studies to shifts in mid-latitude weather, possibly influencing heat waves, droughts, and severe winters thousands of kilometres away. The frozen seas are not isolated. They are deeply entangled with the living fabric of the planet. And yet, for all the science and concern, there remains a strange beauty in the frozen seas. The shifting flows creak and groan as they move, opening lanes of dark water that refreeze overnight in intricate patterns. Icebergs drift among them, sculpted into arches and towers by sun and spray. Under a low polar sun, the landscape glows in hues of gold, blue, and violet, as though the world were painted with cold light. To witness this environment is to feel both its fragility and its majesty, a world that seems eternal, yet is constantly remade. The quiet retreat of frozen seas is one of the clearest indicators of change in our time. It is a transformation we can see from space and measure with precision, yet it carries with it more than numbers and graphs. It is the story of polar bears searching for ice, of penguins waiting for flows that never come, of hunters navigating thinner ground, of krill populations dwindling. It is also the story of the Earth's energy balance, of sunlight absorbed instead of reflected, of feedback loops set in motion. In reflecting on the frozen seas, we are reminded that ice, though fragile and temporary in its seasonal forms, underpins entire systems of life and climate. Its absence is felt in the rhythms of animals, in the patterns of storms, and in the rising of seas. The frozen seas may seem far from most of our lives, but their influence reaches every corner of the globe. They are mirrors, regulators, and habitats, shaping both nature and human destiny. The next time you picture the polar regions, do not see them as empty wastes of ice. Picture instead a living mosaic, algae blooming in hidden channels, seals basking on floes, whales gliding beneath, penguins shuffling across frozen platforms, and bears pacing the edges in search of prey. Picture the creaking and cracking of ice as the planet breathes, and the shimmering horizon where frozen sea meets endless sky. And then picture what it means when that horizon begins to vanish, leaving open water where once there was a frozen sea. High in the mountains of the world, where air thins and peaks touch the sky, lie immense reservoirs of frozen water. These glaciers, perched on lofty ridges and nestled in deep valleys, are more than just scenic wonders. They are lifelines, feeding the great rivers that sustain billions of people. Known as the water towers of the world, mountain glaciers act as natural cisterns, capturing snow in winter, storing it as ice, and releasing it gradually as meltwater in summer. Without them, some of the most densely populated regions of the Earth would struggle to survive. The Himalayas hold perhaps the most dramatic example. Stretching across thousands of kilometers from Pakistan to Bhutan, this colossal mountain range hosts over 50,000 glaciers. These icy bodies feed the Ganges, the Indus, the Brahmaputra, the Yangtze, and the Mekong, rivers that support nearly 2 billion people. The glaciers act like seasonal spigots, releasing water during the dry months when rainfall is scarce. Farmers in the plains of India, Bangladesh, and China depend on this steady flow for irrigation, while entire cities draw drinking water from these rivers. It is no exaggeration to say that the glaciers of the Himalayas are arteries of life for much of Asia. One of the most famous of these glaciers is the Gangotri in India, which feeds the Ganges. For Hindus, the river is sacred, worshipped as a goddess, and its source in the glacier is revered as a holy place. Pilgrims journey to Gaumuk, the glacier's snout, to see the icy cave from which the river first flows. Yet even here, at this spiritual centre, the retreat of ice is evident. The snout has receded by kilometres in recent decades, a tangible reminder of how climate change reaches even the most hallowed landscapes. The Indus, vital for agriculture in Pakistan, also depends heavily on glacial melt. Without the seasonal trickle from the Karakoram and Himalayan glaciers, fields along the Indus plain would wither. The Brahmaputra, by contrast, receives its waters from both glacial melt and monsoons, creating a complex system where changes in ice have profound consequences downstream. For all these rivers, the Himalayan glaciers function as regulators, smoothing out extremes of drought and flood, turning unpredictable precipitation into more reliable flow. The Andes of South America tell a parallel story. From Venezuela in the north to Chile and Argentina in the south, glaciers crown the high peaks of this continent-spanning mountain chain. In Peru, the Quilcaya ice cap, once the largest tropical ice mass in the world, has been steadily shrinking. Its meltwater feeds rivers that sustain communities in otherwise arid valleys. In Bolivia, the loss of glaciers has already altered daily life. The Chacaltaya Glacier, which once provided water to La Paz and even supported a ski resort, vanished completely by 2009. For farmers and city dwellers alike, the disappearance of ice is not just a distant scientific concern, but an immediate crisis of water supply. The Alps, though smaller in scale, have long been iconic in their relationship with ice. Their glaciers carved out famous valleys, and their melt feeds rivers like the Rhine, the Rhone and the Po. These rivers carry water to millions of people across Europe, nourishing vineyards, fields and cities. The Rhone Glacier in Switzerland, which once reached nearly to the valley floor, is now covered with white blankets in summer, a desperate attempt to slow its retreat. Tourists who once marvelled at its shimmering blue ice now walk farther each year to glimpse what remains. In Austria and Italy too, glaciers are shrinking rapidly, transforming not only the hydrology but also the tourism economies that rely on skiing and alpine beauty. Across the Atlantic, the Rocky Mountains hold their own frozen treasures. In Glacier National Park in Montana, the park's very name recalls its icy heritage. Yet of the roughly 150 glaciers that existed in the late 19th century, fewer than 30 remain active today, and even these are shrinking. These glaciers feed rivers that flow across the Great Plains, providing crucial water to ecosystems and farms. Their decline is a reminder that even regions far from the poles depend on high mountain ice for stability. Mountain glaciers act not only as sources of water, but also as buffers against climate variability. During years of low rainfall, meltwater can keep rivers flowing. During times of abundance, the glaciers store snow that releases slowly, preventing catastrophic floods. They moderate the extremes, offering consistency in a world where weather is often fickle. When these glaciers diminish, the rhythm of rivers becomes more erratic, swinging between scarcity and surfeit. The ecological impact extends far beyond human needs. Cold glacial streams support specialized fish, insects and plants. As glaciers retreat and rivers warm, these species face disruption or extinction. Alpine meadows, fed by glacial melt, bloom with unique flowers that disappear when water flow changes. In the Himalayas, entire wetlands depend on the steady trickle from melting snow and ice, hosting migratory birds and sustaining grazing animals. In the Andes, the cultural landscapes shaped by terraced agriculture rely on predictable flows that vanish when glaciers shrink too far. There is also a striking symbolism in these mountain glaciers. To climb high into the peaks and see the white tongues of ice stretching downward is to glimpse something ancient, a connection between sky and river, between snow and soil. In many cultures, these glaciers are sacred. In Tibet, mountains draped with ice are revered as the abodes of deities. In the Andes, offerings are made to appas, the mountain spirits believed to guard the glaciers. For climbers, scientists, and locals alike, glaciers embody more than water. They are symbols of endurance, beauty, and the delicate balance of life at high altitudes. And yet the changes are undeniable. Satellite images reveal shrinking extents year after year. Aerial photographs show valleys once filled with ice now bare and rocky. For the billions who depend on them, the question is not whether glaciers will retreat, but how quickly, and what that retreat will mean for rivers and livelihoods. Some scientists warn of peak water, a stage when glacial melt provides maximum flow, followed by decline as glaciers vanish. For Asia, South America, and parts of North America, this turning point may come within decades. Despite these sobering realities, there is a quiet resilience in the systems that glaciers support. As they retreat, rivers do not disappear, though their flow patterns change. Ecosystems adapt, though often in unpredictable ways. Humans innovate, building reservoirs, altering farming practices, and developing new technologies to capture and store water. Yet none of these can replace the unique role glaciers play as natural water towers, slowly releasing their bounty in a rhythm shaped by altitude, temperature, and time. The mountains of ice remind us that water is never just liquid. It can be frozen into reservoirs perched above valleys, invisible to most until the summer melt begins. It can flow silently for centuries, only to vanish within a generation. It can sustain billions, yet slip away almost unnoticed until the rivers falter. Standing at the foot of a Himalayan glacier, or gazing at a shrinking tongue of ice in the Alps, is to confront both the grandeur of nature and the fragility of the systems on which we depend. These mountains of ice scattered across the ranges of the world are quiet guardians of rivers, cities, and farms. They are the true reservoirs of life, far more ancient and patient than any dam or canal. Their importance cannot be overstated, for they hold not only water but balance, turning unpredictable snow into steady streams. And as they shift and retreat, they remind us of the delicate interplay between mountain and plain, between frozen heights and fertile valleys. Their fate, written in melting ice and changing rivers, is also our own, entwined with the lifeblood they release drop by drop, year after year. Ice and ocean are companions of contrast, one solid, the other fluid, yet bound together in a relationship that has shaped Earth's past and will determine much of its future. Nowhere is this more visible than in the sight of an iceberg drifting across the sea. These vast sculptures of frozen freshwater, carved from the edges of glaciers and ice shelves, are both beautiful and dangerous, towering above the waves yet hiding most of their bulk beneath the surface. Icebergs are reminders that the ocean is never entirely liquid, and that frozen water belongs as much to the sea as it does to the land. The birth of an iceberg begins when a glacier or ice sheet meets the ocean. At its edge, the frozen mass fractures, and a chunk breaks free, crashing into the sea with a roar like thunder. What emerges is a floating mountain of ice, sometimes as large as an entire city. The majority of its mass, about 9/10, remains hidden beneath the surface, invisible yet dictating its motion. Ocean currents and winds then take over, guiding the iceberg on a slow journey that may last months or even years. Some drift into shipping lanes, hazards for sailors who can only guess at the enormity lurking below. Others wander thousands of kilometers before finally melting away into the sea. Beyond their danger and beauty, icebergs play a role in ocean ecology. As they drift, they carry with them dust and minerals collected on land. When they melt, these nutrients are released, fertilizing the ocean and sparking blooms of plankton. These microscopic organisms form the base of marine food chains, meaning that the journey of an iceberg can influence life across vast stretches of ocean. In this sense, each drifting mass of ice is not merely a hazard or curiosity, but a vessel carrying cargo essential to life. History, too, is written with icebergs. The sinking of the Titanic in 1912 remains the most famous reminder of the dangers they pose. But while ships have collided with icebergs for centuries, the deeper story lies in the way great floods of icebergs, known as Heinrich events, have reshaped global climate. These events occurred during the last ice age, when enormous armadas of icebergs broke free from the Laurentide ice sheet in North America and spread across the North Atlantic. As they melted, they released fresh water on a massive scale, altering the density of seawater and disrupting the circulation of currents. These sudden floods of meltwater are known as meltwater pulses. They have punctuated Earth's history with dramatic consequences. One particularly striking episode, Meltwater Pulse 1A, occurred about 14,600 years ago, when sea levels rose by nearly 20 metres in less than 500 years, an astonishing pace by geological standards. Such rapid changes transformed coastlines, drowned low-lying regions, and reshaped human migration routes. They demonstrate how the release of ice into the ocean is not simply a matter of rising seas, but a force that can reorganize entire systems of climate and habitability. The reason these pulses are so disruptive lies in the way the ocean circulates. Earth's oceans are not stagnant, they operate on a conveyor belt of currents known as thermohaline circulation. Warm salty water flows northward at the surface, cools and sinks in the North Atlantic, driving a deep current that loops through the global oceans. This system transports heat around the planet, moderating climates and distributing energy. Introduce a massive amount of fresh water from melting ice, and the balance shifts. Fresher water is less dense, and if enough accumulates, it can slow or even stall the sinking currents. Evidence suggests that such disruptions have happened before. The Younger Dryas, a sudden return to near-glacial conditions about 12,800 years ago, may have been triggered by meltwater flooding from glacial lakes in North America. As ice dams broke, torrents of fresh water poured into the Atlantic, disrupting circulation and plunging the Northern Hemisphere back into cold. In ice cores from Greenland, the temperature drop appears with startling abruptness, underscoring how quickly climate can change when ocean systems are disturbed. Today, scientists watch closely as Greenland and Antarctica shed ice into the oceans. Greenland in particular is adding fresh water at a rate that may influence the Atlantic meridional overturning circulation, a key part of the global conveyor belt. While a complete shutdown of currents is unlikely in the near term, even a slowdown could have profound effects, shifting rainfall patterns, intensifying droughts in some regions and altering monsoons in others. The oceans remember ice, and they respond to it in ways that ripple across the globe. Yet amid the science and the concern, there is still a quiet poetry in ice-meeting ocean. Picture a lone iceberg drifting under the midnight sun, glowing blue against dark water, its surface carved into arches and ridges by wind and wave. Imagine the sound of waves slapping against its sides, the creak and groan as it tilts and rolls. These scenes carry a strange serenity, as though the iceberg is both monument and traveller, a fragment of frozen land wandering the sea until it vanishes. The interplay of ice and ocean also shapes culture. Inuit hunters navigate among floes, reading the ice and water as guides to safe passage and successful hunts. Sailors through history have feared the polar seas not only for storms but for the lurking presence of icebergs. Modern travellers to the Antarctic or the coasts of Greenland speak of awe at seeing ice stretch to the horizon, a seascape both alien and profoundly beautiful. For many, the sight of ice drifting across the water is a reminder of Earth's extremes, where land and sea blur into a frozen frontier. As glaciers and ice sheets continue to release ice into the oceans, the story of their interaction grows ever more important. Each iceberg that calves, each pulse of meltwater, is part of a long dialogue between frozen water and salt water, a dialogue that has shaped coastlines, climates and ecosystems for millions of years. The seas carry away the memory of ice, but in doing so, they are changed by it, warmed or cooled, freshened or salted, stable or disrupted. In reflecting on this relationship, one cannot help but notice the duality of ice in the oceans. It is fragile, melting away in months or years, and yet powerful enough to alter global systems when released in great volume. It is temporary in its drifting forms, but eternal in its influence on climate. It is a hazard to ships, but a lifeline to plankton blooms. It is at once a threat, a resource, and a wonder. The oceans hold many mysteries, but one lesson is clear. The fate of ice is inseparable from the fate of seas. When we watch an iceberg float past, we are not only seeing a block of frozen freshwater, but a symbol of a deeper process that connects continents, ecosystems, and atmospheres. The frozen fragments drifting across dark waters are more than scenery. They are reminders that the Earth is always balancing, always shifting, and always carrying forward the story of ice and ocean together. The story of ice is not finished. Its past may stretch back billions of years, and its present may dominate the poles and high mountains, but its future is still unfolding. What happens to glaciers, ice sheets, and frozen seas over the coming centuries will shape coastlines, climates, and the rhythms of life for generations to come. Ice has always advanced and retreated, waxed and waned, but today the pace of change is unprecedented. For the first time, the frozen world is being reshaped not only by natural cycles, but also by human influence. Projections of melting vary depending on how much the planet warms. In a world that limits temperature rise to well below 2 degrees Celsius, many glaciers will still shrink, but the great ice sheets of Greenland and Antarctica may remain relatively stable. If warming climbs higher, however, the losses accelerate. Greenland alone holds enough ice to raise sea levels by over 7 meters if it were to melt entirely. Antarctica holds nearly 10 times as much. These numbers are not expected to be realized in the near future, but even small percentages of melting translate to meters of sea level rise, enough to redraw the map of the world's coastlines. Already, seas are rising by about 3 to 4 millimeters per year, a pace faster than at any point in the past several thousand years. Much of this rise comes from thermal expansion, water swelling as it warms, but an increasing share comes from melting glaciers and ice sheets. For island nations and low-lying deltas, even these modest changes are disruptive. Salt water infiltrates groundwater, storms reach farther inland, and once stable communities are forced to adapt. The great cities that line the coasts from New York to Shanghai, from Lagos to London, are all watching the horizon with a new unease, knowing that their fortunes are tied to the fate of distant ice. And yet the future of ice is not a story solely of decline. It is also one of resilience, adaptation, and discovery. Ice has retreated before, and life has adjusted. Forests have marched northward after ice ages, rivers have carved new paths, and humans have found ways to live with shifting landscapes. While the scale and speed of current changes are daunting, humanity has shown remarkable ingenuity in facing challenges. Coastal defences, smarter infrastructure, and innovative water management are being developed worldwide. Some communities are experimenting with floating architecture, while others restore wetlands as natural buffers against rising seas. The frozen future may reshape our world, but it need not erase it. Science, too, offers hopeful threads. The study of glaciers and ice sheets is advancing rapidly, aided by satellites that measure subtle shifts in elevation, radar that peers through kilometers of ice, and drones that map crevasses from above. These tools give us unprecedented insight into how ice flows, how it fractures, and how it responds to warming. With knowledge comes foresight, and with foresight comes the ability to prepare. In this sense, the very act of studying ice is an act of preservation, a way to understand and anticipate before change becomes crisis. There are also efforts to protect the smaller glaciers that provide crucial water to communities. In the Andes and the Alps, experiments are underway to cover sections of ice with reflective blankets, slowing summer melt. In Ladakh, India, villagers build ice stupas, artificial glaciers designed to store winter water for release during spring planting. These projects may be small compared to the immensity of global change, but they reflect creativity and resilience at the human scale. They are reminders that people can work with ice, not only watch it vanish. Preservation also takes the form of memory. Scientists are now storing samples of ice cores in secure vaults in Antarctica, ensuring that even if glaciers disappear, their ancient records of atmosphere and climate will remain. These frozen archives hold stories of volcanic eruptions, dust storms, and greenhouse gas levels stretching back hundreds of thousands of years. To preserve them is to preserve the memory of Earth itself, a gesture of continuity in a time of flux. For all the concern about melting, it is worth remembering that ice will not vanish entirely. High peaks will still hold glaciers, and Antarctica, despite losses, will remain cloaked in ice for millennia. Winter snows will still fall, rivers will still freeze, and polar seas will continue their seasonal breathing. The frozen world may diminish, but it will not disappear. There will always be places where ice endures, monuments of resilience in a changing climate. The future of ice is therefore a blend of fragility and persistence. It will retreat in some regions, remain in others, and transform landscapes as it always has. What is new is our awareness, our ability to see and measure, to anticipate and adapt. We live in a time when the frozen parts of the planet are more closely observed than ever. Their every fracture and surge tracked from orbit. This intimacy with ice brings with it a responsibility to listen, to respond, and to consider the consequences of our actions. There is something quietly humbling about this realization. Ice has shaped continents, carved valleys, and regulated climate for billions of years without any need for human recognition. Now, for the first time, its fate is intertwined with ours. The decisions people make about energy, forests, and atmosphere will determine how quickly glaciers retreat and how high seas rise. Ice has become a mirror, reflecting not only sunlight but also human choices. And yet, in contemplating the future of ice, one finds reasons for wonder as much as worry. The very fact that we can study ancient air in bubbles of Antarctic ice, or watch the flow of Greenland glaciers from satellites orbiting hundreds of kilometers above is remarkable. The frozen world is no longer distant and unknowable. It is close, legible, and full of stories waiting to be told. In this sense, the future of ice is also the future of knowledge, a realm where each discovery deepens our connection to the planet. Perhaps the truest reflection comes in recognizing that ice has always been both fragile and enduring. It melts in a day under the summer sun, yet it survives in sheets kilometers thick for millions of years. It can vanish from a mountain in a generation, yet persist at the poles long after human cities have risen and fallen. In its duality lies a lesson about resilience and continuity. The future of ice is uncertain, but uncertainty does not mean emptiness. It means possibility, of adaptation, of coexistence, of reverence for the frozen landscapes that remain. When you imagine the centuries to come, picture not only shrinking glaciers and rising seas, but also communities finding new ways to live, scientists preserving ancient ice, and children gazing at snowy peaks still gleaming in sunlight. Picture the resilience of life adjusting to change, and the persistence of ice in its many forms, from mountaintop glaciers to frozen seas that will continue to appear each winter. The frozen world is changing, but it is not ending. And as long as ice remains, sculpting, reflecting, recording, it will continue to remind us of the deep patience of the earth and the enduring rhythms of a planet forever in motion.